Today's presentation will be about taking away the restarting Alfresco step out of our daily development cycle. So first, a little note about myself. So I started Alfresco development only last year, but I started out in embedded application development using JDK 1.1, which was a lot of fun. Think back to AWT for the guys of you who still know that technology. It was really client-fed apps on embedded devices, and after that I switched to single-page web applications. I try to be an occasional GitHubber as well, and other than that, we are developing all things Alfresco at Xenit, which is located right next to Stella Artois in Leuven, Belgium. Okay, so last year I had my first experience developing Java, Alfresco extensions, and well, the steps might look familiar to many of you. So first off, you discover the Alfresco API. Simple enough, you can create some extensions, write some code, and then you start with the Spring configuration. And if you are trying to make a web script, also you add a web script descriptor XML, and then package that all up as an M file, stop your Alfresco server. So this is the part where it's not so agile anymore. And then when your Alfresco server is down, apply the AMP. It merges your custom files into the Alfresco war file, and you restart your server. And often you will go off doing something completely different and lose focus, because we all know restarting an Alfresco server does take some time. So with some past experience in dynamic deployment of code, I went shopping for a better solution. And I found a very nice solution called Dynamic Extensions for Alfresco, which is a GitHub project that's been around for somewhat over a year. I can't take credit for it. It's created by Laurent Van der Linden, who has many Alfresco projects up his sleeve, but this is definitely the most active project he's working on. You can also check out his Twitter account, where he's posting updates on his latest projects. So, which is the problem we want to tackle in the first place? Well, as I said, I don't like restarting Alfresco, and I'm guessing you don't either. So let's try to reload our Java code online without stopping the server, without using scripting languages, just Java code and reload it. So why is it that we have this idea in our heads that if we're using JavaScript, no problem, just copy paste it to the server, hit refresh in your browser, and we expect it to run the latest version of our code. Very normal. But with Java code, we find it very normal that we're creating artifacts, stopping our server process and applying it, and basically losing a lot of time when we are doing agile development. So how much time would you think it should take to develop a Java-backed web script? Well, let's have a look in this demo. So I set up a bare bones project, which is based on Gradle. That's a competitor to Maven, you could say. But I could have just as well used Maven. I won't yet go into the details of this build file, but the most important thing to note here is that we are applying the Alfresco Dynamic Extensions plugin. And that will take care of some steps for us. So we have no source code yet in this project, just a build file. So let's make a sample Helloworld web script. So we start off by creating a new class. Great. This class, in order to be functional as a web script, we want to register it as a Spring component. So just add an annotation from the Spring stereotype annotations. And that's all it takes to define this class as a Spring singleton bean. Next, as I said, we want to create a web script. No problem again. But this is just an empty class, so let's say we want to start serving web requests at /hello. Well, just add a method for that. For it, say hello. And if we want to say hello to the world, what do we need? We need a web script response object. So we just add it. We haven't implemented any interfaces here, so there is this convention that if you add a specific type of parameter, it's injected for you. So now that we have the response object, I guess you know this part. So we get a writer and we write some text saying hello. Okay, an exception, no problem. We add this to the class, to the signature of the method. What we have not done yet is define at which URL we can find this WebScript. So this is where you would normally use the WebScript descriptor file. In this case, we're using the URI annotation. And if we look at the parameters, there are many, but there's only one important one, and that is the value for the URL. So we want to host this method. We want it to serve responses at the /hello URL. Now what I'm doing here is I'm using Gradle via IntelliJ. I could have done this just as well via command line, which is compiling my code and contacting a WebScript in Alfresco, uploading my bundle, uploading the jar file, and starting my extension. So all in all, that took 2.5 seconds. So if you have a look at the index, so we specified /hello. Okay, that's working fine. Let's see if the reload part is working great. Barcelona, we create a new version and upload it. 2 seconds later, we have new Java code running as a WebScript. So that's nice as a static demo, but just to be complete, let's add the node service. Okay, we have it. So we're using Spring's auto wiring. Have not used any Spring XML here. So let's use the node service to get the root nodes for the workspace store. Okay, we have all the root nodes, and then we write out picked the wrong one. This is what I wanted. Okay. And we have the node refs for all the root nodes in our repository, showing you that you can use all the standard Alfresco services by simply auto-wiring them in. Okay. So as we've seen, it's reloading code online has nothing to do with the dynamic typing of a language. It's not because you're using JavaScript, which is dynamically typed, that you can reload. Clearly, we saw that Java code can be reloaded just as well. So what's going on here? Well, it turns out that in Java, we cannot reload classes themselves, but what we can do is recycle the class loaders that have created classes. So when you're starting up an Alfresco or a Tomcat, what happens is there is a set of class loader objects that are reading .class files from your file system, from jar files, and instantiating class objects for you. So the trick used here was to, for every new version of code we're uploading, is throwing away the old class loader and creating a new one. So I've prepared another demo which shows completely unrelated to Alfresco how you can create this yourself. So I've prepared a daemon here, custom reloader. Let me show you what's going on here. So what this daemon is doing is it's continuously scanning using JDK's file notification service, scanning a directory for any changes to a test.java file. So if we have a look in our project, you can see that we have a special dedicated dynamic source folder. And in this folder, we have a very simple, just to show you the principle, test.java with a main method, just printing out to the output stream. So the daemon is running here first time. So what happens if I make a change and I save? Then you can see that the file system watcher picked up the change in our source file, was able to compile it, and then execute it. Something else that's important when working with reloading code is, you see this class loader finalize statement. That means that it was capable of disregarding our old class loader. So why is this important? Imagine that you're 50 times updating some code, and all those class loaders cannot be garbage collected. Well, you'll run out of perm gen memory. I'm sure We've all bumped into that problem. So it's very important if you're doing something with class reloading that your class loader is recycled. So let me show you the implementation of the reloader. So as I said, it's watching source files, but that's unrelated to the reloading we're doing. But what's important is when we detect a change to our test Java file, is that, well, we're asking the JDK to compile it, and then we're creating here a new class loader pointed to our class output directory, and then using reflection, fetch the main method and invoke it. So that's a useful demo for a demo, basically. That's not something we can use if we're going to start with large-scale modular Alfresco development. So what you need is something like a proven technology like OSGi, which supports the notion of having a large ecosystem with several modules which can interact, which can exchange classes, which can use each other's services. And that specification, which we know as OSGi, has been around for quite some time, also used by many popular products, such as Eclipse and Confluence. They use OSGi behind the screens to support their plugin architecture, meaning that in both products you can upload new plugins also without stopping your entire process. So some background on OSGi. It was founded in about 2000, so it's been around for quite some time. And initially, it was designed as a solution for multiple vendors to be able to create apps and deploy them on remotely running embedded devices. So nowadays, we know this concept very well as app stores, and our phones are all capable of receiving new apps without having to reboot our phone as soon as there is a new version of an app. So it's the same principle there. But when OSGi started out, it was very much targeting client software and not so much server software, like Alfresco here. So I said OSGi is a specification, it's not an implementation. That means that there are a set of guidelines included, and there are multiple implementations available. One of the more popular ones is Apache Felix, and that's also the one used by dynamic extensions for enabling the reloading of code. What's important in OSGi is it's all centered around the idea of bundles. Bundles are no more than jar files with a more elaborate manifest. So you might know jar files have a file manifest.mf. Well, in the case of bundles, there's some extra information in those manifests saying, okay, in order to run, I need commons lang, maybe version 3.1, and I export these classes in turn to other bundles. So other bundles can declare a dependency on me in turn and use the classes that I expose to them. There's also a bundle API. That bundle API allows bundles to get a list of all the bundles that are active in the system, get a view on the relation between those bundles, start, stop those bundles, and so on. I also mentioned versioning. So bundle A can, for instance, use version 2 of a library, whereas another bundle running in the same web application can use an entirely different version of that library. This is not something you can do in a normal web application. You can only have one version of a library inside of one web application. Outside of class files, there is also service interaction. So bundles can have a bootstrap behavior, start up, and register services like a geo service or a search service, and make it available to all extensions running within the OSGi container. You can think of the OSGi container as a type of app server. Finally, if we like, we can also apply security to our bundles. So for instance, we could say, okay, you can install this bundle, but when it runs, I only want it to have network access. I don't want it to have file access, or I only want it to have file access to this particular directory. It's the same technology that's used for applets. And it's also the same way how we configure bundles to be restrained in that regard. So here we see a diagram of a minimal OSGi container. One bundle you will always find is the core bundle. So that's the framework itself. And of course, the core bundle exports the entire API, the org OSGi specification. So for instance, if an extension wants to get a listing of all the other bundles, it will need those OSGi classes. So those are made available by default by the core bundle. Something else we see is 2 supporting libraries. So I already spoke about having 2 versions of common slang, for instance. So in this case, 3.1 and 2.6 are available. You can see that they are resolved and not started. The difference is, in order to be startable, you need to have some bootstrap behavior. So not all bundles have a activator, that's the way they call it in OSGi. So some bundles are just resolved and they expose the class files that are available within them, such as common slang. Common slang, if you use it in an OSGi container, it shouldn't have any active behavior. It should just give us access to the string utils class and so on. So why are we using 2 different versions here? Well, we can see that we developed a custom extension and that there's also a separate geo service running. And those 2 bundles are each using a separate version of common slang. So in OSGi, there's no problem to have this type of dependency. You can see that extension A has expressed a need to have at least version 3, so you can express a range of class files that you need. Okay, when the fat client phase was over and people were starting to look at using this OSGi technology in a server environment, for instance, to allow hot reload of code, of plugins, just like we're trying to do now for Alfresco, they looked at combining Spring with OSGi, and at first they failed miserably. Why? Because Spring, especially in its early days, did a lot of reflection caching. So when you define a bean, the first thing Spring would do is scan all the fields that are inside it, look for setters, setters and getters, and store all that data in hash maps. Now the problem with that is, if you are keeping reference to the reflection data of a class, then you are keeping the garbage collector from recycling the permgem memory it allocated to that code. So basically, every time you would upload a new version of a bundle, it would keep piling up the permgem memory until your system will come crashing down. So Spring decided to support the OSGi through a dynamic modules project. So they created a separate project and they started refactoring the caching of metadata. They introduced some new stuff like a bundle resource loader, so you can load properties file from your bundle. A new scope which matches the startup and the shutdown, so the life cycle of a bundle. And also an XML syntax, much like we know it for regular Spring Beans, to allow you to export services to other bundles. Unfortunately, it didn't turn out that successful for Spring Source, and they decided, okay, this is not our core business, so we ship it off to the Eclipse Foundation, and they redubbed it the Gemini project, where it still lives on today. So, okay, by now we're trying to look for a link with Alfresco. So how can we view these dynamic extensions inside Alfresco? Well, if we have a classical extension and the dynamic extensions, both are running inside Alfresco. But the large difference is that classical extensions live in, most of the time at least, in a global, the main Spring context that's loaded by Alfresco. So beans at a global level. So alongside the node service, the policy component, we would define our own beans, unless of course we are using subsystems. So dynamic extensions installs itself next to this global Spring context and starts up, fires up an embedded OSGi container. This allows it to shield its extensions from this outside Spring context, and any extension or dynamic extension you will develop will be isolated from the main Spring context. So this means that beans defined at a global level, like the node service or any classical extension you developed, will not have any visibility on your dynamic extensions. But the other way around, if you look at the relation, every extension started up in this OSGi container gets its own Spring context, much like the subsystem, but it gets a parent pointer to the main Spring context. What this enables is when a dynamic extension wants to reference, for instance, say the node service, then automatically through the hierarchy in Spring, it will find the node service not in its own context, but in its parent context. So Spring context will always look up in the chain until they find a certain dependency. Okay, enough technical background, so let's see how we can use those dynamic extensions and start developing features. So first off, there are quite a bit of Spring goodies. For those of you who do not like writing Spring XML, good news. We already saw in the small WebScript demo that we used some stereotype annotations. And how is this backed? Well, through bundle class path scanning. You might know class path scanning in Spring for normal applications. And you might also know that it can be very slow at startup. Why is this? In normal situations where you have a very large class path, which is not scoped or modular, Spring has to go through the entire class path, all the jar files that you are using, all the libraries you're using, just to find class files that might be annotated with Spring component annotations, for instance, or auto-wired annotations. But in this OSGi context, we can keep this scanning very narrow because we know it's only inside the bundle itself, which is very small. It only contains our code that we wrote and not the dependencies that we need. So it's very fast, and that's what enables the whole add component behavior, add auto-wired dependency injection. So this is an example of a web script much like the demo I showed you just before. So let's go over the details. First thing we declared was the add component. So that's the equivalent to creating in Spring XML a bean tag. And then there's the WebScript annotation, which does not really do a lot except for allow us to provide a description, provide a family, much like we do in the WebScript descriptors. Most important thing is at a method level. So we see the URI annotation. That's what maps a URL to a specific method inside our web script. And then, as I explained, there is a convention that, for instance, if I want to use the web script response, all I need to do is add it as a method parameter. The framework is clever enough to figure out to map it to the underlying web script object. Yeah, we'll see another example of more options for injecting arguments into these methods. We can also do request parameter binding, for instance. But first, I want to show you a small comparison of an annotation, a dynamic web script, and the classical web script, Java-backed web script. So for dynamic extensions, all we need to do is create one file. That's our web script class file itself. We annotate it just as I showed you, and there's nothing special configuration-wise to be done. Whereas in the classical approach, we have to write the Spring XML, and we have to create a descriptor file in the proper location matching the bean ID. So there is much more chance for error in the classical approach than as we just saw in the demo. So here's an example of doing something more advanced for this method parameters. For instance, request parameters. So say somebody calls our web script with a name parameter. Well, we can add a variable to our method name. It will know to map it to the correct parameter. And by adding this request param annotation, that way we can tell the framework to look for that parameter, inject it, and also define it as either required or optional. You can look at the project's wiki for even more advanced examples. There's also a module attribute provider, which allows you to do much more advanced stuff. Now, printing out Hello World is good enough for a demo, but often you will want something like free market templates to either generate HTML or JSON or XML, what have you. The way to tell the framework that we want to not render the output ourselves via our WebScript response, but delegate a model to a template is by returning a model. If our return type is not a void, but is a map of string to object, then the framework interprets that result as the model to be used and to be passed on to our free market template. So here we create map with just one parameter, the name we received through the web request, and then the framework will start looking based on the class name and the method name for a correct or a matching free marker template. So how does this work? As you can see in this example, first thing it will look for in the same package as our code, it will look for a file starting with the class name, followed by the method name, followed by the HTTP method, and finally followed by the response type. And of course, it always has to end in free marker template. Now, something more interesting that you can also do is provide error pages at different levels. You can provide error pages for a specific method, or you can define it at a global level. So say that you have a WebScript controller that for some reason throws an exception and sets the response status to 404. For instance, we've passed in a node ref which does not exist, so WebScript controller throws a 404, but we want to have in our entire project a nice user, well, a very good-looking error page and not a stack trace. So it suffices to define a HTML 404 page FTL in our project, and that will be shown in case a 404 HTTP error is detected. So that's WebScripts. Now moving on to behaviors. So that's something you will very often need Java for. Unfortunately, we can also do that with dynamic extensions. It's very similar to the WebScript. So again, we turn it into a Spring Bean by adding the add component annotation. And then we specify, in this case, it's a behavior and not for any type, but in this case, specific for all Xenit documents. Next, we have to implement the interface we want to use. So in this case, we're interested in new aspects being added to any Xenit document, for instance. So as we are implementing the interface, that's exactly the same as we would be using Java behaviors in classical extension development. The only difference is we're not directly binding behavior, using Java behavior instances to point via reflection to some method. We're directly, just by annotating it, it's directly registered into Alfresco. And then the actions, as you can see maybe on this example, you don't see any class definition here. That's because actions are defined at a method level and not at a class level. So any Spring Bean can contain actions simply by adding the action annotation on a method. You have to specify, of course, an action ID. That's the ID that you see in Share, for instance, when you're setting up rules. And the drop-down for the actions, that's the main ID for the action. If you like, you can also only have it apply to specific types. You can use complex parameters. For instance, if you want to use share forms when invoking an action, that's also possible. Again, we don't use any interface here, so again, by convention, if we specify a first parameter, like you see here, the node ref, the framework will insert the node ref upon which the action was applied. So if you create a rule in share, you say, okay, execute this action, then the node ref, for instance, a new document was added to a folder, then the node ref of that new document will be inserted here as a parameter to the method. And then finally, this is a fairly new feature in the framework, part of milestone 6. That's a set of easily usable point cuts and advices. As you can see from the syntax, it's fairly clear what it does. It uses Spring's AOP support to allow you, for instance, annotate a method saying, okay, this method should always be run as the system user, as the admin user, or this method should always be run transactionally by wrapping it in a call to the retrying transaction helper. What might be more interesting is it's not so hard to create your own point cuts and advices. For instance, let's say we want to introduce a new NSA advice. Well, we have to extend this abstract class called method annotation point cut advisor, and we have to specify two things. First, what is the annotation that will trigger our advice? Well, in this case, whenever a method is annotated with private, we trigger our advice. And what's the advice? Well, record all. So the way to read it, whenever a method is annotated as being private, our advice is record everything and ship it back to the NSA. Okay, we wrote some code now, but standalone, it's no fun without deploying it on Alfresco. And what I used in the demo before is the Gradle plugin that comes with the framework, and it allows you to very rapidly and with minimal configuration deploy it onto a running Alfresco, be it in development, be it in production. So the plugin adds one task called install bundle, and we do have to configure it minimally. Of course, we need the login for our Alfresco, for a local development machine, admin, no problem. And it's running on a local host in this case. You can also do it manually. There's a web interface which allows you to upload it. But as we saw in the demo, this allows you to very quickly iterate in your development, and in 2 seconds time you can compile your extension and test it in a running Alfresco. So some configuration to be done is for the bundle manifest. So I mentioned the class path scanning. So in order for the framework to pick up our Spring Beans, we do have to tell it in which package it can find Spring Beans. So in our case, it will scan down all sub-packages. We're saying everything inside EU Xenit can be considered a Spring Bean if it's annotated with the correct stereotypes, like component. And then we have 2 more instructions. That's bundle vendor description. That's mainly useful for in the interface when you have the listing of the bundles. You will see it as a form of documentation, but it's not a strict requirement. Okay, if you're getting started with dynamic extensions, I advise you to check out this project. Just clone it from GitHub, and it contains some examples for WebScript actions, just about anything that the framework supports. And it allows you to really easily create your own WebScripts, for instance, and start deploying them onto your local Alfresco test server. So if you're not really keen on writing your own Gradle build file or Maven build file, just check out this project and get started. And then you can get some inspiration on how to set up your own projects. So if some of you are really die-hard Maven fans, have no fear. As dynamic extensions are OSGi bundles, you can fall back to the the Felix plugin, which allows Maven to build OSGi bundles, which boils down to creating a jar file and filling up this manifest file. The only thing that Maven will not do for you is deploy your extension once the jar file is built to a running Alfresco. So once the jar file is built, go to the control panel, the dynamic extension dashboard, and upload your extension. Okay, we've seen how we can use it. Something that's also interesting, at least to me, is how the framework pulls off some of these nice ways of developing web scripts and so on, this declarative way of developing. Well, say we have this web script example, which is serving at 2 different URIs. Well, the framework will detect those URI annotated methods, rip out those methods, and wrap them in annotation WebScripts. Now, what are these annotation WebScripts? They are the part that takes care of handling, for instance, generic before handlers. That's something you probably know from Spring MVC. So before any URI handling method is invoked, for instance, I want to always prepare some data in my model that should be present for all methods. It will take care of injecting WebScript requests, response, attribute providers, and so on. Also exception handling. If you like, you can define some specific exception handlers. Say, for any time an illegal state exception occurs, I want this class to handle the result. Maybe prepare a model for a custom error page if anything you might need. Also the template matching, as we saw, so detecting which FTL file he should look up whenever a WebScript method is invoked. All that logic is contained inside the annotation WebScript. Now we have WebScripts, but that doesn't mean we can start serving up web requests or web responses in Alfresco. We have to tell Alfresco at some point, okay, here's a WebScript, here's the URL at which it will be serving up web responses, and that's the URI index. Now, if you look at the main methods in Uriindex, we have a register method and a find method. The register method is, as you can imagine, the way of creating or registering new web scripts, whereas find is used by Alfresco itself. Whenever a web request comes in, then it will look up using URL, okay, which implementation is serving up these types of web requests. Now, we are using dynamic extensions, meaning that these extensions are installed, uninstalled, updated. And if you're removing or updating an extension, that means at some point you have to uninstall or unregister your web script. Unfortunately, most of the Alfresco API does not support removing or unregistering stuff. So how is this solved? By introducing an extra registry in between those two parties. And when we install our web script for the first time, what will happen is the web script itself will not get registered with Alfresco, but a proxy will get registered. This proxy, in turn, contains a link to the actual implementation. Why is this done? Well, in case our extension is uninstalled, we can simply cut the link between the proxy and the actual implementation. This way, our implementation can be garbage collected and we can deploy a new version. So, an updated web script is installed, it's registered, and as you can see, we don't create or register a new proxy, we simply update the pointer of the proxy to point to the new implementation. So this is a workaround required for dynamically registering and unregistering web scripts. One caveat, the Uriindex has an internal cache, and this cache also caches void responses. So this can be troublesome when, for instance, if you have not yet installed an extension that you know responds at the URL /a, for instance, and then you try to open that URL in your browser, what will happen is the Uriindex will look for a web script, find nothing because our web script has not yet been installed, and in its cache it will put, okay, /a, there is no web script that's available to handle that. Whenever a new request comes in for /a, it will directly look in the cache and it will keep on saying there is no web script. Even after we install our extension, it will keep on saying there's no web script handling this method. So in those rare cases, what you do, you go to the Alfresco service index page, Alfresco/service, and you have to refresh the web scripts manually. Now, behaviors have somewhat the same problem. In the policy component, we see a bind or several bind methods, which allow us to bind new policies, but there is unfortunately no unbind behavior. So the solution is fairly similar, not exactly the same. First step by the framework is converting our annotated classes, wrapping them in Java behaviors, and then wrapping the policy component with a facade that whenever we bind Java behavior, instead of directly binding and passing on our behavior into Alfresco, again, we create a proxy, meaning if we uninstall our extension, we can simply open up the proxy and say, cut off the link with the actual implementation. Unlike with the web scripts, we're not reusing these proxies. We keep on adding proxies every time, but proxies that were created for extensions that are no longer running, that were uninstalled, are set to, disabled, you could say, and have no more behavior. Okay, finally, action methods. That's a bit of a special case because the Alfresco action service expects every action to be a global Spring bean. As I said, the dynamic extensions are all living inside a nested Spring context, meaning they cannot register themselves as bean in the global Spring context. So what we do here is we hijack the reference that the action service has to the main Spring context, and whenever a call to get bean comes in, we interpret that request ourselves and we have a look at our dynamic action registry and we look, do we have an action matching that name? If so, return that reference. If not, simply delegate to the original Spring context. So what happens when you execute action do it now, for instance, action service will ask the Spring context, give me bean, do it now. And in this case, because we inserted a facade in front of it, we can get access to those dynamic behaviors or actions in this case that are located in embedded Spring context. So, as I've heard from some people who tried dynamic extensions, there are some moments where you might potentially get this, what the, you know, this is not working out for me feeling. It's not working out of the box. By the way, this is not to be confused with a lightning talk given by Boris tomorrow. But let me give you some pointers at how you can start debugging any potential issues. So a very nice feature of dynamic extensions is the dashboard. And let's have a look at that. So when you install the dynamic extensions AMP, one of the applications or dynamic extensions that's included is the control panel. And that's what we are seeing here. So this entire page that's all the OSGi bundles that are running. But it's divided in two groups. The extension bundles that are the Alfresco specific extensions. All the framework bundles you see below are supporting bundles that are strictly OSGi bundles providing the infrastructure needed to run our Alfresco extensions. But when you are developing your own extensions, your extension will show up here. And what's very important is that in the status, it should be active if everything went well. But for instance, if you are creating an extension and you're referencing a dependency which is not present in Alfresco, then you will see that the status is stuck in installed, and you can go to the details page to manually start the extension, and it will print out the exact reason why it's not capable of starting. It will also, if you're using the Gradle bundle, it will also print out in the shell, okay, I can't start it because I could not find commons lang 2.3, for instance. So that's the list of extensions. You can see here all the dependencies required for this bundle with the version or not. And we can also see exported packages. So these are the packages implemented by this extension and made available to any other extension. Next, we have the WebScripts list. Why is there a separate WebScript list? Well, as you can guess, the standard Alfresco service page, which normally lists all the WebScripts, does not include dynamic extension WebScripts. So you have to go look for your WebScript here. So for instance, we can see our sample Helloworld WebScript that we created just before here as a WebScript. And then finally, we can move on to the container. That's the core framework. So this is really for troubleshooting. For instance, if I depend on a library that's not included with Alfresco, well, what happens the first time you install dynamic extensions and you start it up, it will scan the full class path of Alfresco, meaning all the jar files that are in webinflip will be scanned for what packages are available, at what version are they, and it will be stored in the repository for performance reasons to cache this information so we don't have to repeat this step every time. Unfortunately, this means, as you can see all packages available in the system class path. If ever you add a new jar file to the webinflip using an AMP file, for instance, then you should go to the container page and delete the system package cache. Then, unfortunately, you do have to restart Alfresco in that rare case, and it will rebuild that file for you. Again, this is in rare cases where you run into troubles with dependencies, for instance. Okay. So, a mysterious screenshot showed up on Google Plus a few weeks ago. I've been preaching dynamic extensions for quite some time now at Xenit. And then my colleague Tess found me using JRebel during office hours. So I had to admit that, okay, JRebel also has its uses. So I guess some of you will have heard of JRebel. It's a comparable tool that also allows you to reload code on the fly. So let's have a look, or let's have a comparison look at both frameworks. First off, when it comes to reloading Java code, JRebel is really good, but there are some edge cases. For instance, if you're changing your superclass, you're working with nested classes, in some cases JRebel will be unable to reload your code. It's rare, but it happens. With dynamic extensions, well, as it completely reloads your extension, you'll never have issues with Java-specific structures. Next, we have a look at the cost. Of course, dynamic extensions, free as in beer, whereas JRebel does have a yearly, fairly steep license. Not to say it's not worth it, but something to consider. Something that's very important, and that I also heard in a talk just before this one, is runtime dependencies. If you're using Alfresco dynamic extensions, you should be aware that you cannot deploy your code without also installing dynamic extensions on the server, which you will be eventually using in production. So all those extensions have a runtime dependency on dynamic extensions. Something you should be aware of, and your customer should be okay with the fact that you're installing this on his production server. Then we have the annotation-driven development. We've seen examples for webscripts, actions, policies. So that's something that really streamlines extension development, makes it really easy to do Spring wiring, create webscripts and so on, and makes it very concise. JRebel just takes care of reloading your code, so you're still writing descriptor XML files, Spring XML files. It does not change the development model, API-wise at least. Next, the generic nature. Dynamic extensions is really crafted for Alfresco development. So it's not something you can use outside of Alfresco. Whereas JRebel, if you're doing lots of, well, very different development, you're doing Spring MVC, Alfresco, well, then JRebel is a really good tool because it can handle pretty much any Java type application using Spring and so on. So it's really a solid sledgehammer that can hit many nails, but it's not as specific when it comes to Alfresco development. Next, something which I find very important is modularity. As our extensions here are loaded in custom Spring context, they have an isolated class loader, meaning I want to develop an extension that uses the latest Google Guava code, for instance. Well, I couldn't do that as a normal Alfresco extension, because I would have a conflict with the version that's shipped with Alfresco. Here I can just declare the dependency as everything is isolated. Only my extension will see that library, and there is no conflict with existing code. Then runtime overhead. So we can use dynamic extensions for development, but in my opinion, it can also be useful for production. There is, unlike JRebel, you don't have the overhead of having to watch your source code all the time. Actually, the overhead is almost none when you're running dynamic extensions. It's only installing the extension that takes time, but executing the code within is just as fast as any other Java code. So some closing thoughts. As I mentioned, downtime, not just developer time, but also production downtime. Many times you have to warn your user that, okay, we're going to install a new AMP, meaning, okay, we're shutting down the server at this time, we're going to apply the AMP, hopefully everything goes well, we're going to restart, check everything, and you've lost at least half an hour. With dynamic extensions, as you've seen, you can redeploy, you can deploy new code in a matter of seconds, and in most cases your users won't even be aware that you uploaded a new extension. Also important, I think, is having one general way to extend Alfresco. So at the moment we have, for instance, document models that we can reload using the data dictionary. We can upload new workflows using the activity interface. We can reload JavaScript webscripts using the service index page, meaning there are lots of different places in Alfresco where we can, one way or the other, reload certain parts. But what we really want is just having a solution in one extension and deploying that, and I want all the included materials, static resources, workflows, web scripts to be updated in one shot. And finally, modularity again. So imagine that Alfresco itself were built as a set of bundles. This would mean that you can, while a server is running, replace, for instance, the CIFS implementation with your own implementation, or start up an Alfresco which is really very lightweight, which is only running the bundles that you need. If you're not interested in FTP, in CIFS, or even permissions, for instance. You can strip all those modules out, and they will not be consuming memory because the class loader will never be loaded. But all those things aside, for me personally, it just makes it a joy to be writing Alfresco extensions. It's instant deploy, little configuration, no configuration. Configuration is an exaggeration. But at the end of the day, what this enables me is having more time for fun with my colleagues and doing some hacking sessions during the hot summers. Thank you for listening. Hope you get started real fast. And if you have questions, shoot away.
Yeah. Thank you. I think this is really something we could use. What I wonder, however, is that the libraries, so all the jar files, all the classes from the application context is available within a Dynamics extension, right?
You mean that the global beans are available for the
Yeah.
Yeah, exactly.
And so I don't see if I put in my own jar file then, which I have to use in my Dynamics extension. Is it packed into an OSGi bundle or what?
Yes, all your dynamic extensions are packaged and deployed inside the OSGi container. So they're installed as a new OSGi bundle inside the container. And because the Spring context inherits the main context, it's able to look outside. So your extension is able to see the node service, but not the other way around. So
because
it's similar.
The jar files are picked up normally from a lib directory, but now they are, how should I say, they're really included in the bundle itself. It's not that you have to upload your dependencies in some kind of directory or...
So if you have dependencies for your extension, there are two ways to go about it. So first thing you can do is add it as a global library like you would right now, and just add it to the webinf lib directory. Then it's available to all the code, normal extensions as well as your extension. Or what you can do is, for instance, I have a test runner framework that I use, which uses Scala. So I upload Scala, the jar file, as inside the OSGi container, and it's a separate bundle. But this bundle is exposing its classes, and if I'm deploying tests that are dependent on Scala, for instance, then it's linked to that Scala jar file. But that Scala jar file remains hidden from Alfresco or any extension that's not declaring a dependency on Scala.
And you could define all those bundles. You can also completely define them in Maven, so your build still is a complete automatic build?
Yeah.
Right.
This, you just add, so first you create the jar file, and for instance if you're using Maven, when using the Felix bundle, what it does is it scans your source code and looks for the code you're importing. So if it detects a dependency on Google Guava, for instance, then in the case of Maven, it will look in your dependencies, see that you've imported in your Maven build file Guava version 2, for instance, and then it will, in the jar manifest file, add a statement saying, okay, this bundle requires Guava 2.
Okay, thank you.
I was just interested in since you have a let's not call it an issue with runtime conflicts. How would you go about locking your dynamic extension to a certain Alfresco version? Is there a pattern you could use there?
Lock.
Yes,
Sure.
say you want the minimum version to be 4.1, maybe, of the enterprise version of Alfresco.
Well, there is a special feature in dynamic extensions that's, for instance, you can annotate when you're referencing a dependency. You can add an annotation. I don't remember by heart what the name was, but you can say if it's not Alfresco version 4 whatever, then don't inject this dependency. But in essence, you can deploy your extension on, it's only at runtime that it might fail, for instance. So yeah, you can create extensions, and it's not like AMP files, for instance, where you say, okay, this is really designed for this or this version. Is that what you're trying to? Yeah. So there's no equivalent to that. You can't say in the bundle manifest, for instance, okay, this bundle is only installable on Alfresco 4, for instance. That's not something you have out of the box. No more questions? Just out of curiosity, has anybody tried to use it yet, or yeah? And have you had success, or just one guy who had success? Okay. So if you have issues, I already ran into someone who had a specific problem. Come see me after the talk, and then we can see what the solution might be for your problem. Okay, thank you. Or one question there.
Maybe last question, if I still have time. I'd like to know what would it cost to, rewrite or re-engineer the subsystem thing that we have in Alfresco based on your technology that you exposed there.
Well,
what would be the effort? Would it be a huge effort, or would it be a minimal effort? Or
it has similarities, but personally I can't say how much effort it would take because I never use the subsystems. Because I think, yeah, OSGi bundles are a better solution because they are truly isolated. They have the same goal, but I couldn't say how much effort it would be to rewrite it. That's something only the Alfresco engineers, I guess, could guess.
Okay, thank you.
Yeah.